Wind power is this massive, multi-billion-dollar industry. But here's the thing, building a wind farm is a huge gamble. So what's the secret? How do you make sure a bet that big actually pays off? And yeah, that really is the question. What makes a wind farm a brilliant investment? Or just a billion-dollar paperweight? What's the real difference between a field of turbines cranking out tons of clean energy and, well, a bunch of giant, expensive sculptures that barely even spin? Turns out, it all comes down to one thing. I mean, just look at the sheer scale of this thing. A single modern offshore turbine is an absolute giant. We're talking blades longer than a football field. It's a beast that can power a whole town. But all that incredible potential is completely worthless if you put it in the wrong place. And that right there brings us to the billion-dollar question. See, this isn't just an engineering problem. Nope, it's a super high-stakes financial gamble. And the key to winning is actually pretty surprising. Okay, so here's the crucial point. It's not about finding the absolute windiest place on the planet. You're not looking for crazy hurricane-force gusts. That kind of wind can actually damage the turbines. You're looking for the right kind of wind, the kind that makes for a smart investment. And this breaks it down perfectly. On one side, you've got bad wind. It's gusty, unpredictable, changes direction all the time. A total nightmare for energy production. But on the other side, that's a turbine's dream come true. Wind that's steady, consistent, and smooth. That's the gold. So how in the world do engineers find this perfect, valuable wind? Well, they definitely don't just guess. They go on a hunt, using a very specific process to stack the deck in their favor long before a single piece of steel ever goes into the ground. This hunt boils down to 3 simple steps. You can think of it like a search for that just right Goldilocks wind. First, they look up. Then they look high. And finally, they look close. Step 1 starts way, way up, basically from a satellite's point of view. They use these incredible global wind maps to find the big regions around the world that have consistently strong and reliable winds. See those brighter colors? That's where it's most promising. This helps narrow the search from, the entire planet down to just a few key spots. Now for step 2. Ever wonder why wind turbines just keep getting taller and taller? Well, this is it. Down near the ground, wind gets all messed up and turbulent from things like trees and buildings. But the higher you go, the faster and smoother that wind becomes. More height literally means more power. It's that simple. And this is the final, crucial step. Once they have a promising spot, they don't just start building. No way. They put up these special towers loaded with sensors. And for at least a full year, a whole year, they just measure everything. Speed, direction, consistency, all to make sure the computer models match the reality on the ground through all 4 seasons. So after all that searching and measuring, how do they actually grade a location? How do they know if it's an A+ spot or just meh? It all comes down to one singular metric. Think of it as the wind's miles per gallon. 30 to 40%. This number right here, this is the magic number. At a great wind farm site, this is what you're looking for. But what in the world does it actually represent? It's called the capacity factor. And here's the important part. It's not just a measure of how often the wind is blowing. It's a measure of how much power the turbine actually produces compared to its absolute maximum potential if it ran at full blast 24/7. The absolute easiest way to think about this is with a car analogy. We all know what MPG is, right? Miles per gallon. Well, this is pretty much the same exact idea, just for a wind turbine. So every turbine has a rated power. That's like the perfect conditions MPG you see on a car sticker. But the capacity factor, that's the real-world mileage you actually get over a whole year of driving on different roads in different weather. The higher that number is, the better the investment. So what's the big payoff for doing all this work? All this careful planning, the mapping, the measuring, the calculating. It's what transforms a huge gamble into something that's much closer to a guarantee. And this is the result. Look at this chart. This shows the explosive growth in wind energy over the last couple of decades. That line doesn't just go up by accident. It's driven by this smart, methodical process that turns wind into a reliable, predictable source of power. So why does all this technical stuff matter to you? Well, because getting it right means more reliable, clean energy on the grid for all of us. It means lower electricity bills, because we're not paying for inefficient projects. And it means a healthier planet and a smart use of our investment in a clean energy future. Ultimately, when you boil it all down, it's pretty clear. The future of wind energy isn't just about building bigger turbines. It's about being smarter about where we put them. Because the best wind power isn't just strong, it's smart. Hey, if you enjoyed this simple explanation, make sure to subscribe to Energy Simply Explained for more. We love breaking down these big ideas into something easy to understand. Thanks for joining us.